Welcome everyone, my name is Alexander Aguirre. This video will end up covering quite a bit. We're going to be going through how to actually make a good data sheet before, how to download R, how to use R, and all the basic statistical programming that you need to know to be able to run a patient-based study. There'll be other videos kind of going over the other basics of statistics. Understand that this whole video isn't about you grasping the exact lines of code and how to memorize those. I'm going to make a actual Word document that you can actually use this to be able to copy and paste into your stuff. R as a software for stats is actually very easy to use. It's seriously a large majority of just being copy and paste. However, you do need to have the knowledge of knowing when you need to use a specific line of code and why. So that is what the purposes of this video is. So use this video not to actually memorize the code, but rather learn how to use the code and then just copy and paste from the Word document. We're going to start by just learning how to kind of download this. So if you look up online, just on a Google platform, just RStudio download, you'll go to this website and click on the button and kind of follow the instructions here to be able to do it. You're going to originally install R and then go through and end up installing the RStudio second. You can keep just the basic R, but RStudio allows you to have this extra benefit of being able to save code, so that way later you can just push Command Enter. But this will be really simple, so just continue to follow these instructions, and if you're on Mac, you can download it this way. Pretty much everything in this video will be on a Mac. So the statistical programming R is actually a Python-based code which allows you to utilize a lot of the basic fundamental properties of Python coding. What this means though is that it is just literally a series of code. R then just serves as a console, kind of like Terminal, where you have to be able to introduce specific language in order to be able to have the program understand what you're wanting to talk about. So that's where the idea of packages come in. So these packages have been developed by other people throughout the world, and they've been able to allow various strings of code to be able to be utilized for very specific purposes. So what we end up having to do is actually install the packages, and you only have to do this the very first time that you actually download R, but then every single time that you open up R, we will call the functions to be able to read the library. So think of these packages kind of like a library, and ironically we end up using a library function to call this, but basically it's a long list of definitions or lines of code. That way when we get to the point of actually doing the statistics coding, what we're going to do is reference these libraries and this set of definitions to be able to actually run our data in a very specific manner. So here you're going to go to Tools and then click on the Install Packages. And then in the search bar, you're going to search for whatever you want to look for. So here I'm going to download ReadXL. And then it's really important here that that button for Install Dependencies is clicked. This is really important because some of the packages have other packages that it's actually dependent on. So instead of having to install each of those individually, this actually allows for all things that the ReadXL package would be dependent on to also be downloaded and kind of streamline the process. So making a data sheet is going to be the most important part of this entire process, because if there are any subtle differences amongst any of the variables within the columns, it actually ends up messing up the stats. So the very first thing I like to do is also minimize the difficulty of actually coding. So here I'm changing all of the actual column names to very simple things. If there's spaces or capital letters, then you actually have to incorporate that into your actual statistical coding. So I like to just keep it simple. I always use this as a totally different data sheet. I make a copy of my data sheet and then I make a stats version of it, which is what I'm doing here, where I'm making all of these things actual codable column names, so that way they can be referenced later much easier. Next, I kind of go through the actual variables and try to simplify them, because sometimes if female is misspelled, male is misspelled, even by the capitalization of it, the R program will actually read that as a totally different variable. So I like to keep it very simple and replace everything with either zeros and ones for no and yes, and then more categorical variables, I like to make them a little bit simple. So here you're seeing me kind of simplify the male and female aspect of this. And now you're seeing me do the same thing with the smoking status, just to be able to simplify that a little bit more. And it's always good to keep a code either on a sheet of paper or something of what you end up changing these to, just in case you forget later if it's not super obvious, especially with things like race or things that aren't just yes or no's. Be careful here. I'm using, again, the kind of find and replace, but if I were to do this for no's and yeses, like you're about to see me do, but I utilize something like non-smoking, that phrase earlier, all the no's would have been changed to zeros. So make sure just at the very end that you have nothing that will actually be affected by other things. Every single time you open R to start a program, the very first thing you need to do is call in all of those libraries, so that way the actual program knows what you want to do. So here I called in the library readxl one, and then I'm going to use the code that is going to be standard to be able to get a actual Excel file into R, which will be the data equals to read.xl, and then I'll do a file.choose, so that way I leave it blank, so that way I can actually choose, it'll pop up with a thing. And then I always make the column names equal to true, because I did a lot of effort to make them actually accurate, right? So it pops up, allows me to go through my computer and select what I want. So here I'm selecting that exact data sheet that I've had. Something really important to highlight is R allows you to actually store whole data sets or whole functions into a very specific name. So here you can see that I actually say that data is equal to this. So not every time I use the word data, it's actually going to call in the entirety of my sheet. And like I said, with the benefit of using RStudio, you can actually save an R script and keep a console separately. So that's what I'm doing now. So that way I don't have to redo the code 1,000 times. I'm actually going to kind of store all this, so that way if I have to redo the stats later or whatever it may be, I actually just open this file and all the code is already written for me. So you can see again that I am setting the word data equal to my actual Excel data sheet that I created. And you don't have to do this twice. I'm putting this into the R script and rerunning the code so it's there just for the purposes of this teaching. To access a column of data within your actual data sheet, you use data and then the $sign and then whatever the column name is. So here I'm accessing age and then have the whole list of ages that were included in this paper. So the two main types of statistical variables are going to be continuous and categorical. So here are just some common examples. So make sure that you have a really good understanding of how to identify which variables in your study are continuous and categorical, because this will be the basis of everything going forward. The next foundational concept to understand is when to use these specific statistical tests. So here, if you have two continuous variables, let's say we have age and BMI, then we're going to be using a linear regression model. You're going to use a univariate model to be able to analyze things simply like age versus BMI, and then a multivariate model will be utilized to be able to develop predictive models later in this video. The next scenario is when you have a continuous and a categorical variable, and this is going to have two different types of tests that you need to understand, which is when there's only two possibilities. So let's say smoking and non-smoking status, and we want to look at that average BMI between the two. Since there's only the yes smoking and no smoking possibility, you're going to use a t-test. When three or more groups are present, then you're going to have to use an ANOVA test, which will just be the same concept of it, but utilize different code within the R program. An example of this would be analyzing the average BMI by race, which does have more than just yes or no answer or more than two groups. The final possibility that can exist is having two categorical variables. So let's say smoking status, yes and no, and then the presence of diabetes, also a yes or no. This will allow us to use a chi-squared for the analysis. This, however, is not limited by a certain number of categories. You can definitely analyze more than just a yes or no feature. Since now we have the opportunity to kind of understand what type of tests to be able to use in certain situations, we're going to kind of walk through a couple of the actual codes utilized to run these tests within R. So here you can see the first one's going to be a t-test, where you're going to be just using two groups. Here you see me having the opportunity to actually call the entirety of a column within my data sheet by using that function I talked about earlier, where you use data, $, and then the name of the column. So here I'm actually calling the age in the complication columns to be able to do an analysis of this. For the t-test, it's very important to know that the continuous variable has to be the first one in this. So you do the continuous variable, the tilde, and then the actual categorical variable. And then you're calling the data function. And then the rest of this line actually kind of serves to just kind of aid on this. So you're going to set the mu equal to 0, and then the confidence interval equal to 95, which is standard for most publications. And then you're going to set the alternative equal to two-sided, because that is pretty standard. There's not going to be many situations where you're actually going to use a one-sided possibility there. So I ran this code for my data, and it spits out this kind of image. What's really important here is to find this p-value. That's going to be the p-value that you're actually going to report in publication. So how I do this is I typically open up an Excel document and start kind of formulating what I want the tables to look like. So that's what I'm doing here. At the end of this video, I show how to change all of these Excel tables that I'm making by hand into actual publication tables. So that's why I'm kind of doing it in this specific way. For a final paper, I'm actually going to be using the mean, the standard deviations typically, or even the median sometimes. But you need to report those alongside the p-value. So the aggregate function, which I'm calling here, is actually a really good way to be able to very quickly do this. So you do aggregate, and then you do x equals to your continuous variables, comma, and then you do a by list, and you call in your categorical variable, and then you do a fun or function, and then you set that equal to mean, and it actually spits it out very quickly for you. And then you're going to see how I can actually copy this entire thing and just change the function to SD, or standard deviation, and then I have my standard deviation as well. And then this just goes into the table. The ANOVA test is going to be a little bit differently because you're actually going to have to store the function and then call the summary of it. So what this means is you can see here that I'm typing in my actual AOV or ANOVA, and I'm putting in my continuous variable, my categorical, and calling those just the same way as I always have, but I'm saving it as the word ANOVA1, and then I called the summary of it. So when you get the summary function, you're actually going to get this kind of look here, but you're going to only really focus in on this p-value right there. And that p-value is going to be the most important part. And you can see me here utilizing the same aggregate functions again, where I'm going to actually just basically copy and paste them and change that variables that I'm actually kind of analyzing. And it actually gives me those means and standard deviations again for all possible groups. And I'm going to put that into my Excel document. The first part of using a chi-squared is that similarly to the ANOVA, you can actually store a function into the word, and then you're going to have to call that later. So here I'm actually making a table between the data of my race and then the data of my complication, and then it's actually going to make a table and already separate it all out for me. So I call that, and then I'm actually going to look at my table. So here you can see this, and it's a really, really quick way to actually, instead of having to go through a data sheet on Excel and count one by one, I'm actually going to be able to have all the individual numbers of race between the two different groups here. And now you call the function chi-squared.test, and you put in just the word table1 because I already stored my table into that, and it pops out your p-value. Here you're going to see the same methodology that we previously used, where we're actually going to store a function, the function lm, and whatever we want to call within it to a specific word. Here we're going to use the word model, and then we're going to call the summary function of that model to be able to get the results of it. Here I'm calling the summary function, and then I'm getting the results that demonstrate the actual beta coefficient, which is the first thing I highlight, or the estimate tab. This is going to be really important when looking at multivariate analysis models, but then the p-value there is really important. And then the very last thing about how you actually discuss linear regression models is by the multiple r squared there. And if you want to visualize this, you're just going to call the plot function between the two variables that you want to be able to do. And this will come up on the right side. You're going to see this plot. And if you want to see how the linear regression fits your model, you just put abline and then your model, and it puts it on there. And if I want to change the color of the actual line, you can see that I'm editing that now. And recall it, and now the line is red. Here you can see just a simple linear regression model, and this is going to be just between two variables. But when you're actually looking at a multivariate analysis to predict an outcome, you're going to look at the summation of multiple variables and how all of these actual beta coefficients or odds ratios contribute to the entirety of it, and it actually makes a model to predict your outcome based on the summation of all of these. This also allows you to be able to highlight significant predictors within these models. It is really important to note, though, here that when you're actually looking at these multivariate analysis models, whatever variable that you're trying to predict, so let's say I'm trying to predict the operative time based on a series of comorbidities, I need to use a linear regression model, which is going to be reported with a beta coefficient, the standard error, and then a p-value. Whereas if I was trying to predict something like, is a complication going to happen, you're going to actually use what they call a logistic regression model, and I'm going to use odds ratios, the confidence interval of those odds ratios, and then the p-value there. And then here in the very bottom, just the phrasing, you can actually see how you would speak about these. And since it's so important, I want to stress it again. If you're trying to predict a linear or continuous variable, you're going to use the linear regression model and you're going to report beta coefficients. But if you're going to predict a categorical variable, you need to utilize odds ratios. So while the multivariate models might seem really complex, it's the code and the ability to do it is so easy. So you're going to use the same exact code that you were with the linear regression model, where you take the LM and store it as a function. Here you can see I'm storing it as the name multi-model, and then you actually put what you want to predict, and then you put the tilde, and then you put all of the variables, the long list of them that you would actually like to investigate or include in your predictive model. So here I'm kind of going through that and putting all the comorbidities and different things of that nature. And then again here, you're actually going to call the summary function to be able to look at your results and how this actually plays. So here, calling the summary. So now looking at the results of this, I'm predicting a continuous variable, so I need to report the linear regression, which is going to be beta coefficients. So this first column here of all of the estimates is actually going to be your beta coefficients, and then here in the very end is going to be your p-value. And then to be able to determine the strength of your actual model, there's the multiple r squared and then your p-value. And it might seem intimidating to make one of those big tables or charts about this type of thing, but it's actually really easy in R if you just copy this and you put it into an Excel. Then you highlight all of these cells here, you go to data, and then you push the text to column button, and then you push delimited, and then by space, and then this will separate all these columns for you. You push finish, and then here I'm just getting rid of kind of just the extra stuff that they kind of provide. And then I'm putting all of these p-values as less than 0.001 since they're so small. That's just standard reporting. And I'm going to label my columns. Like I said in that thing earlier, you're going to use the beta coefficient, the standard error, and then the p-values to report. So you can get rid of the column that is just the t-values, and I end up moving everything over, cleaning this up, and then I'll show you how to make this into a table a little bit later in the video. Now, let's say that I come to the next part of this where I want to predict, is a complication going to happen based on these factors? So I can just copy it. I want to look at the same factors. I change the op time to complication, but now complication is going to be yes or no, or a categorical variable. So now I'm going to have to use odds ratios and confidence intervals. So now you can kind of see I call the summary function. So you're going to use this. I'm just making sure there's complication. I'm going to take all of this. Like I said, you're not going to use the beta coefficient or the standard error here, but what you need from this is actually the p-values. So you end up doing the same process all over again, and then I end up deleting everything except for the actual p-values. I'm now going to type out this code that I just had on the previous slide, but you're going to do the exp or exponent to the cbind to be able to do your coefficient, and you make sure to use whatever you use as your model name. For me, it's multi-model, so I'm calling the coefficients of the multi-model, and then the confidence interval as well. The confidence interval is standard at 95% confidence interval with 2.5 on top and bottom. So that's why it gives you two different things here. So you're going to get the range of the confidence intervals. That first column is going to be your odds ratios, and then the next two are going to be your confidence intervals. So here I'm going to call the round function to be able to do it because you only report out to 2 decimals. So you do equal round, you click on the cell you want to round, comma, and then how many decimal points you want to go out, which will be 2. And then you end up just dragging it all the way down, dragging it over, and now you can actually combine this very easily because you report confidence intervals in brackets. So the code will be a little bit different for every single person depending on where they actually put this, but in this case, when I say cell location, what I'm talking about is the actual location of the cell, like F55 in this case, and then the second location would be G55. So you're going to kind of see that I do this to get this final product, and then I drag down on the bottom right corner to extend it all the way. Then you can just copy and paste it right in between the p-value and the odds ratio columns, and then get rid of all the bottom. Make sure when you're actually copying it, you copy it and then you paste the values. So you paste special values, otherwise it'll completely ruin it. Since I'm trying to take you all the way to the final table, here I'm just actually doing a couple other variables to make the table a little bit more, but also just trying to demonstrate how easy it is to copy and paste that actual code and be able to replicate this for all the different variables that you want to do. To start, you want to be able to copy from the Excel that we made into a Word document and then merge that top row, relabel it as table 1 with a period, and then what you want it to be titled. Then you want to underline this or put a border on the bottom, same with the row below it. Then I'm changing the plus and minus into the advanced symbol of the plus or minus sign, and I'm doing that for both, copying and pasting it to the second row, and then now centering all of these. Race has individual categories, so I'm actually going to indent them within the cell. So I'm going to highlight the cells and drag that little gray over to the right. And same with type of surgery, those are going to be differentiations of it. Now you want to merge these cells for any of them that have multiple rows within them. And then you want to go up to table properties. You're going to center it within the cell. Then you're going to click on the bottom cell and tab to get another row below it. Then you're going to go back up to the very bottom, add a line to be able to do this. Then you're going to merge the bottom one and then left justify it. And then here I'm going to put my distinction here. You can also put abbreviations and acronyms here, which is also a good reference for any kind of things within it. Categorical variables should be represented with a number, and then typically put the percentage in the parentheses. So you see here, these are not accurate percentages, but I'm just going through to demonstrate the final product here. You should also, in the very top or the title, put an N, or the total number of people within the group. For me, I actually didn't know what this was, so I can use R just to make a quick table of just the complications, and it gives me my total number. And this will be my final table that I can submit for publication. I have the beginning of this just sped up very fast because it's going to be similar to the table 1 of just formatting the heading. So now you want to be able to edit the actual variables. Anything that's a continuous variable, you actually want to denote that in this. This is really important when you're looking at odds ratios or different things within a logistic regression model, but regardless, you want to denote what is continuous and what you treated as an actual categorical variable. And just like the demographics table of table 1, you're going to take the last variable, highlight it all, and then make a borderline on the bottom. And then you're going to add one row below. And then here I'm going to merge all the cells and then make my statistical statement as well. But first you want to be able to put the acronyms and abbreviations tab there, and you want to define anything that you abbreviate within your table, so that way there's a really clear reference for anybody who needs it. Everything outside of the variable should be left justified, so I end up doing that here. For the final table, all things should be rounded to the same thing, typically beta coefficients and standard errors to 3 decimal points. Here I'm not rounding, I'm showing the final product, but then the actual p-value should be rounded to 2 decimal points. Table 3 is going to do the same exact process that you did for the second one, but this is what the final product looks like with the odds ratios and then the confidence interval. Here everything is rounded to 2 decimal points, but the same exact methodology.